Let us find out potential energy of a system of charges. So be careful about this. We are trying to find potential energy, not the potential. Okay. Potential, we already know that potential is V is equal to 1 upon 4 pi epsilon naught Q upon R. But here we will find out or derive the potential energy. So start with a very basic setup in which there are only two charges, Q1 and Q2, with position vector R1 and R2 relative to some origin. All right. Due to these two charges, which is at two positions, okay, from maybe some origin O here, and this is our R1 and that's our R2. All right, and here we will place these charges Q1 and Q2, but and then we have to find out the potential energy of this system of charges. But to do that, we will not just start with placing these charges right here, but we will think that we are bringing these two charges from the infinity. Okay, so these two charges are not here from the beginning, but these two charges will be at infinity, and we'll bring it, and then we'll establish the potential, and then we'll find out the potential energy. We can bring any of these two charges from infinity first. Okay, so order is not important. So let's say that if we bring charge Q1 first from infinity to the point where the position vector is R1. Okay, this is at the infinity. Now to bring this charge from infinity to the point where the position vector is R1, there is no other charge here, which will exert the force on our charge Q1. So there is no force. So when there is no force, we can easily move it from infinity to the point where the position vector is R1. Okay, so we can easily move it here. Since there is no force, then there will be no work done. Okay, so just to bring it here, the potential of will be 0 because there is no work done. So actually work done is stored as the potential energy. As we know, work done in bringing Q1 from infinity to R1 is 0, and this is the work done that is stored as the potential energy, but for this we have done nothing. But to bring other charge, that is Q2, from infinity to this point where the position vector is R2, we have to do some work. Why? Because on Q2 there will be a force exerted by Q1. So if we bring it here, a force is exerted by Q1, and because of this force there is a work done in bringing this charge from infinity to that point, and that work done is stored as the potential for Q2. So potential at this point by Q1 is actually V is equal to 1 upon 4 pi epsilon naught Q1 by R12, and our R12 is the distance between these two charges right now. Okay, and because of Q1 only, there is a potential at this point. Now we can simply apply the work done formula, and that is work done is at work done on Q2, on this charge Q2, is actually what? Q2 multiplied by the potential, and that is equal to 1 upon 4 pi epsilon naught Q1 Q2 by R12. And as we know that electrostatic force is a conservative force, That's why this work done will be stored as the potential energy, all of it. So for a two charges system, the potential energy is 1 upon 4 pi epsilon naught Q1 Q2 upon R12. Okay. Now potential energy is denoted by U. Okay. And our U is actually Q1 V. So as in the book it is written that the potential energy of a system of two charges Q1 and Q2 is this. Okay, let's bring more charges in the system. Earlier it was only two charges, now there are three charges. So what will happen now? First of all, as you can see, this is Q1, Q2 and Q3. Let's say that from the infinity we will bring one charge first. Let's say Q1 will bring Q1 first. To bring Q1 from infinity, okay, Q1 from infinity to this point, there is no work done. Why? Because there is no other charges, so there is no other forces exerted on Q1, so there is no work done. The moment we bring Q2 from infinity to this point, what will happen here? A force will be exerted by Q1 on Q2. Okay, so to bring it on to bring Q2 from infinity, we have to do a work done, and that work done, as we know, would be equal to Q2 and potential due to Q1, that is our V1. And when we will bring the charge Q3 from infinity, then there will be two kind of forces exerted on Q3, one by the Q1 and other by the Q2. Okay, and because of that force we have to do some work done, and that work done will be stored as potential energy that we know, but that work done will be Q3 potential multiplied by the potential due to Q1 charge, that is V1, and also Q3 multiplied by potential due to V2. And the total work done would be, we'll just add everything. So Q3 V1 plus Q3 V2 plus Q2 V1. Okay, and these work done is actually what? The work done is stored as the potential energy. So this is also the result of the potential energy. Now we know V1. What is V1? V1 for Q3 is actually Q3, and then V1 is 1 upon 4 pi epsilon naught. V1 is Q1 divided by R13. Okay, and Q3, then here V2 is 1 upon 4 pi epsilon naught. V2 is Q2 upon R23. Okay, and the third one, Q2 V1 is actually Q2, and V1 for Q2 is 1 upon 4 pi epsilon naught. V1 is Q1 divided by R12. Alright, so here we can take common 1 upon 4 pi epsilon naught, that you can see it is everywhere, and in the bracket what will be left? Q1 Q3 by R13 plus Q2 Q3 by R23 plus Q1 Q2 by R12, and that is the potential energy stored, and it is also the work done in bringing all these charges from infinity to these positions, and we can say this is the potential energy of the system of charges. And here it is 3 charges. We can increase it to n charges, okay? N number of charges, okay? And what you really have to keep in mind that order is not important, which one you bring first. And why we are bringing the charge from infinity, or why we are thinking like let's bring it from infinity? Because it is very easy to derive at potential energy through potential, okay? And to establish potential, we know that we have to bring the charge, we have to think in a way that we bring the charge from infinity to that position, and then we can easily talk about potential, right? I hope you understood the concept. If there is any confusion, you can always write the comments on the video. And also I suggest you can always go to www.proteacher.in and you can go to 12th physics, and there will be more notes, study notes, materials, and also all these videos are aligned there as well. Thank you.